Download this code from codegive.com, link in the description below. OK, let's dive into the world of dataweave streaming, specifically focusing on handling different data formats in Part 1. This tutorial will cover the fundamentals of dataweave streaming, the core benefits, and how to implement it, with particular emphasis on XML, JSON, and CSV, along with code examples. We'll also address the limitations and common gotchas. Part 1, Introduction to Dataweave Streaming with Different Formats. 1. What is dataweave streaming? Dataweave streaming is a powerful feature within MuleSoft's dataweave transformation language that allows you to process large datasets without loading the entire data into memory at once. Instead of processing the whole input, dataweave iterates through the input data in smaller chunks or streams, transforming and outputting data as it goes. Core concepts **** chunk-based processing ** data is processed in small, manageable units, chunks. * lazy evaluation * dataweave evaluates expressions only when needed, minimizing memory consumption. On-demand transformation * transformations are applied to each chunk as it is processed, instead of waiting for the entire input. 2. Why use dataweave streaming? * reduced memory consumption * this is the biggest advantage. Streaming enables you to handle datasets that would otherwise exceed available memory, preventing out-of-memory errors. This is crucial when dealing with large files, database results, or API responses. Improved performance * by processing data incrementally, the transformation process can start sooner and finish faster, especially when combined with asynchronous processing. The initial results are available more quickly because dataweave doesn't have to wait for the entire dataset to be loaded. Scalability * streaming allows your Mule applications to handle larger workloads without requiring significant infrastructure upgrades. Handling infinite data streams * streaming is essential for processing continuous streams of data, example from sensors, message queues, or real-time data feeds. 3. When should you use streaming? Consider using dataweave streaming when large data files * you're dealing with large files, example XML, CSV, JSON, that are several gigabytes or larger. Database result sets * you're processing the results of a database query that returns a large number of rows. Real-time data * you're working with continuous data streams. Memory constraints * you have limited memory resources available. Performance requirements * you need to minimize transformation latency and improve overall throughput. Data filtering / selection * you need to filter out a small subset of data from a massive dataset. 4. Dataweave versions and streaming support. Dataweave 2.0, Mule 4 streaming is well supported and optimized in Dataweave 2.0 and above. This is the version used in modern Mule 4 applications. Dataweave 1.0, Mule 3. While Dataweave 1.0 has some streaming capabilities, it's generally less efficient and less feature-rich compared to Dataweave 2.0. Migration to Dataweave 2.0 is highly recommended for optimal streaming performance. 5. Enabling streaming in Dataweave. Streaming is often enabled by default for some input formats like CSV and XML. For others, you might need to explicitly enable it through configuration properties. 6. Data formats and streaming considerations. Here's how streaming applies to different data formats. CSV Dataweave can efficiently stream CSV files row by row. XML Dataweave can stream XML documents using the Stacks streaming API for XML, parser, which allows processing large XML files element by element. *JSON* streaming of JSON is supported. Dataweave parses JSON as a sequence of tokens, allowing it to process JSON data without loading the entire structure into memory. *Other formats*. For other formats, the effectiveness of streaming may vary. Dataweave typically reads the entire input into memory if it cannot be easily processed incrementally. 7. Code examples, streaming with different data formats. Let's look at some practical examples of streaming with CSV, XML, and JSON. I'll show the basic structures and considerations for each. 7.1. Streaming CSV. CSV is inherently well suited for streaming because it's row-oriented. Each row can be processed independently. Explanation *. %DW 2.0 * specifies the dataweave version. *output application /JSON * defines the output format as JSON. *input payload application /CSV use streaming equals true * declares the input as CSV and explicitly enables streaming. The use streaming equals true is important, though CSV streaming often happens by default. If it's not streaming automatically, adding this attribute will force it. *payload map, row, index, dash. ***. This maps each row of the CSV to a JSON object. The map function processes each row individually. *row.id as number ** accesses a specific column by name, ID, and converts it to a number. *assumptions assumes that your CSV file has a header row, example ID first name last name email. If it doesn't, you'll need to configure the CSV reader accordingly, example header equals false and access columns by index, row 0. Example CSV input, data.csv. Output JSON *. Key considerations for CSV streaming *. Header row * ensure you handle the header row correctly. You might need to skip it or use it to define column names. Delimiters * specify the correct delimiter if it's not a comma, example semicolon, tab. You can specify the delimiter like this: input payload application /CSV use streaming equals true, separator equals. Character encoding * be aware of character encoding issues, especially with non-ASCII characters. Configure the CSV reader to use the appropriate encoding, example UTF-8. Input payload application /CSV use streaming equals true, encoding equals UTF-8. Error handling * implement error handling for malformed CSV rows. Dataweave provides error handling mechanisms to catch and handle exceptions during transformation. 7.2. Streaming XML. Streaming XML is more complex than streaming CSV. Dataweave uses Stacks, streaming API for XML, for efficient XML processing. The XML structure significantly impacts how you can stream. Explanation *. %DW 2.0 * specifies the Dataweave version. Output application /JSON * defines the output format as JSON. Input payload application /XML use streaming equals true * declares the input as XML and enables streaming. Payload employee map, employee, index, dash. This assumes the XML structure has a root element and then a repeating employee element. The employee selector iterates through each employee element. Employee.id as number * accesses the ID element within each employee and converts it to a number. Example XML input, data.xml. Output JSON asterisk. Key considerations for XML streaming asterisk. Asterisk XML structure asterisk. The XML structure is critical. Streaming is most effective when you have repeating elements at a certain level, like the employee element in the example. Deeply nested structures or complex dependencies between elements can make streaming difficult or impossible. Asterisk root element asterisk. Dataweave needs to know the root element of your XML document. Asterisk namespaces asterisk. Handle XML namespaces correctly using the NS directive in dataweave. Asterisk attributes asterisk. Access XML attributes using the @ symbol, example employee @ department. Asterisk stacks limitations asterisk. Stacks is a forward-only parser. You can't go back to a previous element once you've moved past it. This can limit the types of transformations you can perform. Asterisk complex transformations asterisk. Very complex transformations might still require buffering some data in memory, even with streaming enabled. Asterisk large text nodes asterisk. If you have very large text nodes within XML elements, streaming might not be as effective because the entire text node could be loaded into memory. 7.3 Streaming JSON. Dataweave can stream JSON, but its effectiveness depends on the JSON structure. JSON arrays are easier to stream than deeply nested JSON objects. Explanation asterisk. Asterisk %DW 2.0 asterisk specifies the Dataweave version. Asterisk output application /JSON asterisk defines the output format as JSON. Asterisk input payload application /JSON use streaming equals true asterisk declares the input as JSON and enables streaming. While JSON can sometimes stream automatically, it's good to be explicit. Asterisk payload map, item, index, dash. Asterisk asterisk. This assumes the JSON payload is an array of objects. The map function iterates through each object in the array. Example JSON input, data.json. Output JSON asterisk. Key considerations for JSON streaming asterisk. Asterisk JSON array structure asterisk. Streaming works best when the JSON payload is an array of independent objects. Asterisk nested objects asterisk. Deeply nested JSON objects might be more difficult to stream efficiently. Dataweave might need to load parts of the structure into memory. Asterisk large string values asterisk. Similar to XML, very large string values within JSON objects could impact streaming performance. Asterisk complex transformations asterisk. Complex transformations that require looking at the entire JSON structure might not be suitable for streaming. Asterisk array of primitives asterisk. If you have an array of primitive types, example 1, 2, 3, 4, Dataweave can usually stream it, but it might not provide significant memory savings compared to loading the entire array. 8. Verifying streaming behavior. How do you know if Dataweave is actually streaming? Here are a few ways to check. Asterisk memory profiling asterisk. Use a memory profiler, example Visual VM, JProfiler, to monitor the memory usage of your Mule application during the transformation. If streaming is working correctly, you should see relatively constant memory usage, even with large input files. If the memory usage spikes significantly, it suggests that Dataweave is not streaming. Asterisk logging asterisk. Add logging statements within your Dataweave script to track the processing of each chunk. This can help you verify that Dataweave is processing data incrementally. For example, asterisk file size and processing time asterisk. Test your transformation with increasingly large files. If streaming is working, the processing time should increase more linearly with the file size compared to when the entire file is loaded into memory. If it does not, there might be an issue. 9. Limitations and gotchas. Transformation complexity. Extremely complex transformations might not be suitable for streaming. If your transformation requires looking at the entire dataset or relies on calculations across multiple elements, dataweave might need to load portions of the data into memory, negating the benefits of streaming. Data structure. The structure of your data plays a crucial role in streaming efficiency. Certain data formats are more amenable to streaming than others. Functions that require full data. Some dataweave functions, example order by, group by, require the entire dataset to be loaded into memory before they can be applied. Avoid these functions when streaming. Error handling. Proper error handling is essential when streaming. If an error occurs during the processing of a chunk, you need to handle it gracefully to prevent the entire transformation from failing. Use try, otherwise blocks to catch exceptions. Output buffering. Even with streaming input, the output might be buffered depending on the output format and configuration. Ensure that your output stream is also configured for streaming if necessary. Memory profiling is important. Don't assume streaming is working. Always verify with memory profiling, especially when you are working with large data sets. 10. Best practices. Start simple. Begin with a basic transformation and gradually add complexity. Test streaming behavior at each step. Profile memory usage. Regularly profile memory usage during development and testing to identify potential memory leaks or performance bottlenecks. Use logging. Add logging statements to track the progress of the transformation and identify any issues. Optimize data structure. If possible, try to structure your data in a way that is more amenable to streaming. Error handling. Implement robust error handling to prevent transformation failures. Monitor performance. Monitor the performance of your Mule applications in production to ensure that streaming is working as expected. This concludes part 1 of our dataweave streaming tutorial. You've learned the fundamental concepts, benefits, how to enable streaming, and how it applies to CSV, XML, and JSON. In part 2, we'll delve deeper into advanced streaming techniques, error handling, performance optimization, and more complex use cases.